So, now let us look at the phase transition. We looked at the phase transition of solids to liquid to the gas. So, now we are going to use a very simple model of hard spheres and see if we create a crystalline structure. Now, if you look at on your screen, you can see it is a nicely defined crystalline structure. It is all created and you are looking at 200 particles of one kind. So, there is no mixing of the particles, it is a pure substance and it is not going to change chemical composition as we move forward. And if you look at here, we are let us look at the averages, we are all at 0 0. I will make that. So, now because this is pre-recorded simulation, you can see and understand different parameters. So, first let us look at temperature versus time, then we look at pressure versus time and energy versus. So, those are the three parameters and then we want to see what happens to these three parameters as we do the phase transition. So, we are essentially giving some heat to the system, heat bath is on, go forward. Now, if you look at here, the temperature was at relative temperature 1.0, went up to 20 times steps, then it went up. As you see, it is going up and so obviously the effect is some of the particles coming out. Now, you can see another jump here as you move forward. So, now you are seeing that the temperature is going up and as the temperature is going up on the left hand side you can see the particles are going away from their original crystalline structure to liquid like structure and now if you go further down then these are all gaseous phase. So, let us rewind it. Now, you can see that it has gone back to the original system. Now, this is a deterministic model. So, now we are going to look at the pressure and so let me also make averages, reset the averages to 0, start again. So, you can see it is starting at 0 pressure and then it will keep going. Now, as we increase the temperature in order to create phase transition, then the pressure also goes up in the system, because as you remember from your discussion that at the lowest energy and temperature, particles are sitting at the bottom of the what we call is potential well. As we give the heat, then they start vibrating very fast. As they vibrate, they are sampling the higher energy states and they are moving away from the equilibrium position. So, at this time now what you are seeing on your screen is that effect showing up in terms of pressure. So, pressure is going up and if you go again forward to that, there is some phase transition that you observe here and that is where the pressure is gone from 0 to all the way to 0.25 Pascal and now this is in the gas phase. Now, let us look at the same phase transition in the idea of energy. So, what is happening with the energy, especially let us look at kinetic energy. So, I am going to again make all the averages 0, start again from 0 level. Again you can see the kinetic energy is 1.0, this goes up to 3.0 and again it is following completely the same path as the temperature, because kinetic energy and temperature are essentially same thing. So, you are seeing exactly same behavior of the kinetic energy. Now, let us also look at total energy, which also includes the potential energy. So, we will look at that. Let us rewind the whole simulation again and I am going to reset the parameters to 0. Now, let us run few steps and see what happens to the energy. So, we are looking at the potential energy bottom here, kinetic energy on top. So, let us look at the potential energy curve here and the one which you are seeing is the total energy curve, which is the summation of the two. So, if you look at both energies are growing up and you can see that this is distinct place where the liquid becomes vaporized and that jump in the potential energy is clear indication of the phase transition. So, if you are trying to understand phase transition, what you will do is essentially draw a potential energy versus temperature curve. You are looking at and if you draw the line at certain point, you will see a jump in the potential energy. At that jump describes the phase transition, sometimes what we call melting. If you are from solid to liquid, then it is a melting transition. So, and that phenomena has been very well studied. So, this is a very good example how we can now traverse through the phase transition processes here. So, now let's go back and look at some of the thermodynamics behind it, because that's an important factor that we want to look at. I'll go back to my slides and shut off magnification. Okay. So, again this is situation where we are looking at the particle which had no gravitational force, it was free of the gravity. Now, let us look at the same experiment quickly in molecular dynamics as a very interesting phenomena if you add the gravity. So, in this case what you are also looking at is gravitational force which is working on all particles going downwards. So, does that affect how the phase transition happens? We are going to look at that situation and understand that. So, now let us go back to our VMDL lab and we look at the solid with gravity. Yes. So, if I now go to higher magnification, so you can see it better. And so, now what we are going to do, we are going to start the simulation here, and let me first show the averages, everything zeroed out, and in this case this is not a movie, this is a real simulation. So, we can adjust some of the parameters as well and see what happens. So, now let us start with the solid, and as we are moving it will remain solid primarily because it is, and also you can see it is at the bottom ground level which is the gravity. So, let me stop it and then I am going to increase the temperature and run that again. So, now you can see immediately it became gas like because I put lot of kinetic energy here. And so, if you look at this parameter, that is a great understanding of gravitational, but if you look at the density is higher at the lower side because of gravity. So, let us do something unusual. We are going to now try to freeze it again and see what happens to it, what happens because of the gravity. So, now here is very interesting phenomena you are observing, that while this gas is becoming solid, because I again put the low temperature, it is going back to the crystalline phase, although it is not going back to the original point of the same thing, but now you can see the same liquid like phase is coming up here. And again if you look at you can add a piston to here also and see some more pressure, and again look at the phase the phenomena of phase transition. Let me stop here, and now from here let us do another temperature cycle. So, we are going to look. So, now these again became gaseous particles. Now, let us pause that and then we are going to go back to the lower temperature. So, we are essentially again quenching them to the lower temperature. So, here is transition again back, and because it is with gravity, what you will see the effect that the gravitational effect will start showing up at certain point. So, I think this is where you can see that gravity then creates another force on these particles when they start looking into the particle simulation. So, the phase transition with or without gravity, obviously we are on earth with certain gravitational force. So, if you really want to understand substances and their phenomena at atomic level, you may also want to invoke gravitational forces to see that as additional force, especially when you are doing chemical vapor deposition etc., forming a very thin layer, you have to account for gravitational forces as well. So, let me stop here, and now next section what we will do understanding the thermodynamic phenomena. Thank you.